Hello, guys. 72 of you who are here. I'll have to mute. Okay. Hey, am I audible? Is it visible? Everything is fine? We'll wait for 5 odd minutes and then we will start. Coke Zero. 103 people have joined in. So a couple more minutes, 5 more minutes, and then we can start. I hope you guys are fine. I'll try to, uh, make it worth your hour. And yeah, I mean, this is only a live. There are no recordings happening. I'm not recording anything. It took me a while to figure this also out because I haven't used YouTube Live except for doc tutorials, and they have a tech team, so they figure it out, and I don't do anything. So yeah, I mean, I'm not recording anything, okay? So this is only once, uh, I mean, this is just going live. Hopefully, I'll do it in future. I mean, never know. So if somebody misses it, it's fine. Don't worry too much about it. I mean, you can read everything, right? I'm not teaching you something which is unheard of, right? It's nothing like that. I'm just teaching you how to use all the knowledge and use it to dissect the antibiograms, and that's about it. Okay, I'm not teaching you something which is out of the world. It's in this world. Everything is in the books. Everything is in on internet. I'm just teaching you how to use it. That's it. Okay. Happy Independence Day, guys. So hello from Nepal, Ashish Kumar Singh. Uh, I mean, we'll start sharp at 9, okay? It's 8:55, so 5 minutes, and then we'll start sharp at 9. And 139 of you have joined in. So I'll give people 10 odd minute to. It's raining very heavily here. Uh, Electricity might act up, but thankfully I have backup internet. I mean, electricity backup is there for internet as well, so hopefully nothing should happen. Very heavy raining. We have an orange alert for like flood and uh, landslide and all that. No, I'm not recording anything, guys. It's just a live. I'm not recording anything. Uh, Thank you, Simanta Sarma. Yeah, this is the first class I'm doing it and doing here, and I mean, I don't like. I like my free time, so I don't do a lot of classes. There is no recording happening, guys. This is only live. There is no recording happening. Okay. So 3, 4 more minutes and then we can start. Uh, it's 8:57. We'll start at 9:91. Okay. I want to ask a few questions, two questions first before we start. So the first question I want to ask is, which antibiotic do you use most commonly in hospital, inside the hospital, not OPD basis, in hospital setups? Which is your most prescribed antibiotics? Can you just put it down in the comments? Piptaz, meropenem, piptaz, ceftriaxone, zone, piptaz, ICU, meropenem. Zone, Magmexport, which is cefoperazone sulbactam, Meropeptase, ceftriaxone, ceftriaxone, I don't know, cephalosporin, peptase, ceftriaxone, cefoperazone sulbactam, cefixime, ceftriaxone, cefepime, tazobactam. Interesting. Ceftriaxone, piperacillin, tazobactam, ceftriaxone, meropenem, ceftriaxone, peptase, ceftriaxone, beta-lactam, zone plus SB. Okay. Colistin. Colistin is your most commonly used antibiotic. I mean, dude, you need to change it. Okay. Uh, Ciplox plus Amica or meropenem, NICU. Okay. Ceftriaxone, cefoperazone, Moxclav. Okay, fine. Uh, like, fine. Piperacillin, tazobactam, ceftriaxone, teicoplanin, meropenem, cefoperazole, sulbactam, ceftriaxone in pediatrics, tigecycline. Same guy who's writing colistin is also writing tigecycline. Man, what are you doing? Cefepime, Zone SB. I think it's ceftriaxone plus sulbactam. Moxifloxacin, a non-medic research scholar, hospital in your hospital, moxifloxacin and tobramycin used mainly for bacterial keratitis. Okay, if it's for the eye thing. Zone, peptase, mero, ceftriaxone. Uh, okay, teicoplanin, MIC, colistin, meropenem, ceftriaxone, ceftavi. Okay, okay. So it'll be interesting, but I mean, you have heard what people have written, right? So let's start in 1 minute, okay? Nitrofurantoin, ceftriaxone, amoxicillin. In hospital, nitrofurantoin. Out of hospital, yes, but in hospital, I'm not sure. Amoxicillin also in hospital. Ceftriaxone, yes, one of the most commonly used antibiotic all over the world is ceftriaxone. Okay, and it shows in your prescribing pattern also. Okay, so let's start. Okay, so good evening to everybody. Uh, the thing is, uh, India leads in antimicrobial resistance. Okay, we do worse than many other countries because the literacy about antimicrobials is not very good. I wasn't taught anything. Basically, I was taught about the drugs when I was, you know, like a medical student, even MBBS during my MBBS days. And then I started seeing what my seniors were prescribing. And I was learning through their prescription pattern. And that is how most of you are also learning. Much of it isn't very rational, okay? Much of it is just whim and fancy and based on personal preference. Not a lot of evidence behind prescription patterns, okay, in India, what I have observed. So, when I got into critical care, I didn't know much about antibiotics. And then I started reading and learning more. So, now, after a few years, I have acquired a decent knowledge. I don't know anything of everything, obviously, but I have acquired decent knowledge to start teaching, and I hope that we can create a better, you know, uh, uh, prescription pattern amongst ourselves in the countries like India and neighboring countries in the Southeast Asian world. Because the problem here is first, ID is not very common. Okay, infectious disease is not very common. It's a it's a new specialty, emerging specialty in India at least. And then many people don't give ID reference even when they are available, and that becomes an issue, a major issue. Okay, so and people like pharmacy can openly give you antibiotics and everything. So people pop. azithromycin like it's candy. So yeah, I mean, lot of things, lot of factors which are causing antimicrobial resistance. Also, the environmental factors are also there, right? A lot of antibiotics being used in poultry, a lot of antibiotics residue being dumped into our water. So that water gets, the sewage and everything. So E. coli gets, exposed to fluoroquinolones, majorly fluoroquinolones, and that is how they acquire resistance as well. So a lot of the factors are there. But what we can change is our prescription pattern and then try to teach the whole world what antimicrobial stewardship is and hope that things get better. Okay. And this is one of those attempts. So, how I read antibiograms, the thing is, a lot of you have asked earlier that, sir, how do you recognize that this is NDM? How do you recognize that this is ESBL or this is, CRE or whatever, KPC or whatever, right? And I have tried to tell people, but I thought, why not do it, like make some videos on it. But then I needed to explain a few things, and I was lazy to, break down and series and all of those things. And when the videos don't do well, I get very discouraged, and I don't want to do it. So I thought, why not do a class on it? Whoever wants to learn can come and learn. So 229 of you are here to learn. Now, how I do that, we will learn. So before we go everywhere, let's start with it. Okay. So imagine you are seeing imagine you are seeing this culture report. So most of you, what you will see is you'll see that this is an E. coli, right? And that E. coli is sensitive to amoxicillin clavulanic acid, and it is growing somewhere. You will probably try to find out that it is you growing in urine or whatever, and then you will try to see that it is sensitive to amoxicillin clavulanic acid, and it is sensitive to ceftazidime, and it is sensitive to ertapenem, and it is sensitive to amikacin, sensitive to gentamicin, sensitive to fosfomycin, intermediate to nitrofurantoin, and sensitive to trimethoprim sulfamethoxazole. Okay. And then some of you will probably see the MIC, the lowest MIC, and then probably prescribe the antibiotics, right? It's all fine. I'll tell you the flaw here, but it's all fine. Yes, that is Coke Zero, not diet. I like Coke Zero more than diet. I'm sorry. Okay. So, this is fine. All this is fine. Till you have a report like this, you feel like this guy who's happy and who thinks he's the king of the world because you have a lot of options, right? You have a lot of options to choose from. So either you give piperacillin tazobactam, you give, cefepime, you give ertapenem, imipenem, meropenem, amikacin, everything seemed to be working, right? Throw your best shot, whichever antibiotic you're comfortable with. Use that, right? Might work, right? But when you see a report like this, then it becomes problematic, right? You don't have a lot of options. Then what to do? You get frustrated, okay? You get frustrated like this guy, this little guy here. So this is where pattern recognition comes in. Now there are multiple hospitals who will also tell you, the genetic makeup of the bug. They will do molecular testing and all of those things, right? And then you might get the genetic makeup of the bug that you have blah KPC, blah NDM, right? The gene is there, okay? Blah is penicillinase, okay? So blah KPC, blah NDM, you might have seen those in your molecular testing reports, right? So that is how you get to know. But what if in many hospitals in India, even the one I work in, we don't have it commonly, right? We don't have it routinely. Then what to do, right? And if you see the guidelines, like this is IDSA 2026 version 5 update for antimicrobial resistance. So they talk about how to treat ESBL, right? Extended spectrum beta lactamase producing enterobacterials. Then they talk about how to treat MC beta lactamase producing enterobacterials. Then they talk about how to treat, Then they talk about how to treat CRE, carbapenem resistant enterobacterials. And then they talk about DTRP, difficult to treat resistant pseudomonas, and then they talk about crab, carbapenem resistant acinetobacter, and they talk about Xenotrophomonas maltophilia, right? So they talk about all of these bugs in the context of the resistance that they have. ESBL, AMPC, KPC, NDM, whatever, CRE. But you don't know that, right? You don't know that. So how do you incorporate these guidelines into your practice? You don't know that. So what if there is a way by looking at what you have available, you can interpret these findings and use it in your practice. So this is what the class is about. This is how I read my antibiograms. Okay. I mean, this is a short class. There are a lot more details, but you will understand. Don't worry. Hopefully, fingers crossed. Okay. So, okay. Now, so, uh, okay. So, most of you have given the answer of which is the most commonly used drug that you have. Okay. And if you have realized, most of you use beta lactams as the most commonly prescribed antibiotics. Most of you have a common prescription pattern. That is, the beta lactamases are the workhorse of your prescription. Okay. Beta lactams are the workhorse of your prescription. Okay. So you use beta lactams more than any other antibiotic, including me, because those drugs are amazing, right? They kill the bug, right? And they give you best result, have the least amount of toxicity compared to aminoglycosides or fluoroquinolone or other drugs, right? Colistin or whatever, right? So those drugs have much less side effects compared to other drugs, and those drugs are wonder drugs when it comes to killing the bugs. Okay, so we will mostly talk about beta lactam because that is what the prescription pattern will be in the hospitals. Okay, so whenever I talk about beta lactams, I'm talking about penicillins, then I'm talking about cephalosporins, carbapenems, and monobactam. So all of these drugs, basically, I'm talking about these four categories of drugs when I'm saying beta lactams. Okay, and these are the ones which are the most commonly prescribed drugs. Okay, so before we go in, a few definitions. So most of you throw around the word MDR, XDR, PDR, right? But you should know what is MDR, what is XDR, what is PDR. Okay, so MDR is that a bug which is susceptible to more than one agent in less than two or less than two categories. Okay, and sorry, did I say something wrong? At least one agent in three or more antimicrobial categories is multi-drug resistance. Okay, XDR is non-susceptibility to at least one agent in all, but two or fewer antimicrobial categories. So only two or fewer categories are there, like which you have, susceptibility in. Rest all are resistant. Okay, pan drug resistant is everything is resistant. Okay. So if two or less than two categories are available for you to prescribe, those are XDR, and then everything else is gone. That those are PDR. Okay. So this is basically what about the definition. Now, how do bacterias? So I'm talking a little bit about all of these things before we go into the main topic. Some context is important. Okay. So there are multiple ways which a bacteria can acquire resistance, but basically four you need to know. Okay. So what happens is a drug enters the cell wall. I'm talking mostly about beta lactams. Okay, here I'm talking about mostly about beta lactams. So drug enters through the cell wall, right? Goes into the periplasmic space, right? Enters through porins, right? Goes into the periplasmic space, binds to penicillin binding protein, right? And then basically destroys the formation of cell wall. Okay, so this is how the drug basically works. Okay, beta lactamases, that is how they work. Okay, so how can you acquire resistance? You stop the entry. So porin loss, those porins don't work anymore. Okay. Then in the periplasmic space, you have an enzyme which cleaves the beta lactamase, right? Sorry, beta lactam antibiotics, right? So if the drug is destroyed, it won't work, right? Third is the penicillin binding protein only you modify, so the drug cannot bind to it, right? So third modification of penicillin binding protein is another way the bacteria can acquire resistance. Fourth is whatever drug is inside, you throw it out. Efflux pumps, okay. So these are the four major causes of resistance in a bug, in a bacteria. Now, can you do anything about porin loss? More or less, no, but you have some drugs like ceftriaxone, tazobactam. So there are certain bacteria which have uh, all of these things. Okay, more commonly these things are seen in certain bacteria. Okay, like Pseudomonas acinetobacter and all of this. Okay. So, and we are mostly here going to talk about gram-negative infections because those are the killer ones. Okay, gram-positive also some things like that happen. They also have some genes like VAN-A, VAN-B, MEK, but those don't require you to think a lot about, the pattern of resistance. Gram-negative bugs here require you to think a lot about pattern of resistance. So this is how that is why we will talk more about it. Okay. Now, so you can't do much about the poor in-laws. Okay, but you have some drugs which will work. Okay, because it depends on actually like so if there is a porin loss, so the drug which is dependent more on porin because the drug molecule is bigger, right? The drug size is like that. So ertapenem, it won't get in, but a smaller drug like meropenem will get in. So it depends on that. So there are drugs which will work through it. Can you do some? But you don't need to worry about it because you can't do much about it. Okay. Can you do a lot about efflux pumps? You can't, right? So there are efflux pump again in Pseudomonas and all of those species. There are certain drugs like ceftriaxone, tazobactam. They work through the poral efflux pumps and all that. You don't have to worry too much about it. There is no pattern per se, and these things produce a very weird pattern. Okay, so porin loss will produce a very weird pattern. Like randomly, some drugs will be resistant. Okay, randomly, there is no categorization. There is no logic behind it. So you will see uh, very weird pattern. Although some drugs like ertapenem is more pore independent, so it will be more resistant compared to meropenem, like I said, right? So things like that you can see and catch, but more or less there will be not a very rigid pattern to it. Same with efflux pump. Okay, so penicillin binding to modification. If you do like in staph, right, there is penicillin binding to a there is a modification of penicillin binding to protein, right? So if that happens, can you do something about it? There are drugs which will bind to the new protein. So use those drugs, but there is no per se pattern of resistance. That drug will become basically the drug which used to bind to the old protein will become resistant, but there is no per se. You don't need to think a lot about the pattern of the most common resistance method is beta lactamases, and those are transmissible. Okay, they are plasmid based, so they can be transmitted to other species amongst the bugs, and they can produce a pattern. And if you recognize those patterns, you can treat your patients better because those are the most common ones, right? So that is what we will focus majorly on here. Okay. Okay. Am I making sense? Can somebody just comment? Like, there's, I spoke a lot. I don't know if I made any sense. Okay. And there are then some other patterns like lipid modification, for colistin and like tigecycline, you have ribosomal protein alteration and all of those. Some other small mechanisms are also there. Okay. So this is what I talked about, right? Porin, drug comes in, periplasmic space. You have beta lactamases, which basically cleave the beta lactam rings, right? And then these are penicillin binding protein where the drug basically attaches. So if the beta lactamases are cleaving those rings won't work. I mean, those drugs won't work. So basically, it is like the Undertaker, right? So beta lactam is entering, and then from behind, Undertaker will come and destroy the ring, right? So destroy the drug. So now, how do we classify these beta lactamases? So there are two classifications. One is Ambler, one is Bush Jacobi. Okay, I'm going to talk about Ambler because that is the one I remember and I find comfortable. There is no logical explanation why I use it, but I find it easy. I find it easier to remember. I remember it, so I use it commonly. There is one Bush Jacoby, which is sort of phenotype based. I don't like it. I don't find it easy. So I don't talk about it. So I will not talk about it. If you can, I am telling you the name Bush Jacoby classification. You can read about it if you want, but I will talk about Ambler classification. Okay. Now, these are classified according to Ambler classification, these beta lactamases. Okay. So there are in four categories A, B, C, D. Okay, it's easy enough. A are the ones which are the first ones. Okay, which are the first ones. Okay, so here you can see in the green there are penicillinases, the ones with destroyed penicillins. Okay, then came ESBLs, okay, extended spectrum beta lactamases, which destroyed. We will go and talk about it, and then carbapenemases came. Okay, so these the red ones are carbapenemases, and then the class C is AMC. Okay, so A are the first ones. So in A you need to remember TEM, okay, SHV, CTXM, okay, and you have to remember KPC. That's about it, more or less. That's about it. If you talk about Pseudomonas, then PES, VB, okay, and that's about it, more or less. In class B are the okay. So there are four classes A, B, C, D. Okay. Now, A, C, and D are called serine proteases. Okay, serine proteases. Why serine? Because they are protein based. Okay, they have a serine protein, a histidine protein, and an aspartate. Okay, aspartate. So they have three amino acids which basically are there, and that is why those are based upon that. So basically, those are proteins, and that is why they are called serine proteases. Class B are metallo beta lactamases. They depend on zinc. Okay, so they have a metal zinc. So they are metallo beta lactamases. They depend on zinc. Okay, so B. Okay, B is metallo beta lactamases. Rest three are serine proteases. It will come in handy. I'll tell you when we reach to beta lactamase inhibitors. Okay, I'll tell you why. So A, C, and D are serine. B is, metallo-beta lactamase, MBL. Okay. Now, so A is the first one. TEM. TEM is basically so all of these are named. They have a logic behind the name. Okay. So TEM is Temora. So it is the person where the last name of the person in whom this enzyme was found, and it was around in 1960 something in Germany, 1965 or something, where this enzyme TEM1 was found. And it was penicillinase. Basically, Staphylococcus had this enzyme. Okay, who used to destroy all the penicillin, and that is why we made extended spectrum penicillins, basically the ones which we use like oxacillin and dicloxacillin and all of those things, right? So it is because this enzyme came in, we started producing those drugs which worked against staphylococcus against, okay. And then SHV1, SHV is sulfhydryl variable, okay. So and like that, CTXM is cefotaximase found in Munich, so CTXM. Okay, and KPC is basically Klebsiella pneumonia carbapenemase. So everything has a name. Okay, so everything has a name. You don't need to remember the name, but I'm telling you that there is a logic behind all of these things. This is not a random. This is not random. Okay, this is not random. So class A, am I making sense? सर ये पार्ट थोड़ा टफ जा रहा है कैन यू मेक इट मोर सिंपलर विच पार्ट Which part is tough? I haven't even reached the tough part. Okay. Type in. I'll continue. Okay. So, so this is class A. Okay, class A. Now, in class A, you have penicillinase, the ones which destroy the penicillin. It's very hot in here. Let me. Class A are the ones which destroy the penicillinase. Okay, then there are ESBL. ESBL are basically which destroy till the third generation cephalosporins. Okay. Okay, and then you have carbapenems. Carbapenems basically they destroy carbapenem. You will understand everything. Okay, and class C is AMC. Okay, AMC also has like AMC is just not just one enzyme. It has many enzymes under it. Okay, it has DHA, it has FOX, it has many other enzymes. Okay, inside it. Okay, but it's like AMC. They're commonly called as MC. Okay, they're commonly called as MC. You don't have to remember that what is DHA, what is FOX, and all of this. You don't have to. And then class D is OXA enzymes. Okay, Ambler class D is OXA enzymes. B is the one which is problematic in India. Okay, NDM is the one which is problematic in India. It's named after, New Delhi, right? So NDM is the major problem in India. Okay, now we'll see the pattern in each. Okay, so this is penicillin. I was talking about, medicine susceptible staph aureus, right? Found in those, right? So it destroyed basically penicillins. Okay, it destroyed penicillins. Rest everything will work on it. Okay. Then you come to TEM1 and TEM2 SHV1. SHV2 is the first ESBL which was found in around 1983 or 84. Okay. SHV2 was the first ESBL which was found. Okay. So these again are narrow spectrum. They will only destroy penicillin and first generation cephalosporins. Okay. Rest second generation, third generation, fourth generation, Betalactamases, Actinum, everything will work. Carbapenem, everything will work on it. Okay. कुछ आ रहा है समझ में? Like, are you able to understand? Am I making sense or not? Okay. Then you have in class A, you have these enzymes. These are, the next generation of TEMs and SHVs. Okay. And then came CTXM. CTXM is ESBL. Oh, one second. Where did I go? Yeah. CTXM is ESBL. Okay. TEM, SHV, the next generation after TEM 3 and SHV 2, they are all ESBL. Okay. They are all ESBL. So what is ESBL? ESBL will destroy penicillin, first generation cephalosporin, second generation cephalosporin, third generation cephalosporin, more or less fourth generation cephalosporin. We used to believe that fourth generation cephalosporin is not destroyed by ESBL earlier, but now we are not sure. We think that it is destroyed because MICs are constantly higher. So IDSA, the newer IDSA guidelines, they don't even recommend using cefepime, fourth generation cephalosporin, basically cefepime. Cefepime in treatment for ESBL infections. Okay. Fourth generation cephalosporin is used only for AMC. Okay. If you have to use for ESBL, they advise you to use it along with N-metazolum. Okay. Okay. Cefepime and metazolum not to be used alone. Cefepime, if you're using, can only be used for UTIs when the patient is improving. Otherwise, they don't advise you to use cefepime at all for ESBLs. Okay, so ESBL destroys penicillin, first generation cephalosporin, second generation cephalosporin, third generation cephalosporin, fourth generation cephalosporin. These are cefoxitin is a cefamycin. Okay, so oxyaminocephalosporins. So the ones which we commonly use, ceftazidime, ceftriaxone, right, cefotaxime. So these are oxyaminocephalosporins, and then there are cefamycins. Okay, so cefamycins are not usually destroyed by these. Okay, cefamycins are left. Okay, okay. Am I making sense? The slides will disappear after the class. We'll see. Uh, I think my video. One second. Give me a second. Yeah, I think video came back. Okay. So then comes, okay, so where was I? Huh. So, okay, and in class D also you have OXA, some initial OXA, some OXAs are ESBL. Okay, so same thing, they destroyed these things, right? The drugs in reds are destroyed, rest others will work. The preferred ones are carbapenems for ESBL. We'll talk about why, Merino trial and all that, and inoculum effect and all of those things. We'll try some other day, or maybe in this class, we'll see how long it goes. Okay. Now, Ambler class, you see, this will all start making sense. Don't worry. Just be present, be patient. By the end of it, you will start recognizing the patterns. I'm telling you, just be present and be patient. Okay. Then comes AMC. Okay. AMC, like I said, there are others. One second. AMC, there are others, DHA and Fox and all of those things. But don't worry about it. So AMC destroys everything except carbapenems and fourth generation cephalosporins. Okay. Carbapenems and fourth generation cephalosporins. So though cefepime is used for treatment of AMC and carbapenems, meropenems are used. So till now, carbapenems can be used for all of whatever we have talked about, right? Whatever we have talked about. So we penicillin, the earlier narrow spectrum penicillinase carbapenems can be used, right? The earlier SHV and TEM carbapenem can be used, right? ESBLs carbapenem can be used, AMC carbapenem can be used, and that is why meropenem is such a wonderful drug because still we had just these problems. Meropenem worked for everything. Just give meropenem and forget about it. It will work. It will cover all the gram negatives. It will cover most of the gram positive except for the drug resistant ones, right? And it will cover the what do you call it the anaerobes, right? So meropenem is such a wonderful drug, and that is why we abused it like anything. And then came carbapenemases. Okay, now they destroy everything. They destroy carbapenems as well. They destroy penicillin. They destroy first generation cephalosporin, second generation cephalosporin, cefoxitin, third generation cephalosporin, cefamycin, basically fourth generation cephalosporin, third generation cephalosporin, beta-lactam inhibitors, estionam, carbapenems, right? Okay, so everything is destroyed by carbapenems. So in class A, there is something called KPC. Okay, KPC, SME. There are others as well, right? KPC, SME. The KPC is the most common one which you have to remember. So I'm naming the ones which you have to remember. You have to remember M, SHV, CTXM, KPC, AMC, OXA, NDM. Okay, VIM, IM. Others are there in B also, but you have to remember NDM. Okay. These you have to remember. Okay. So KPC is from class A. Okay. It destroys everything except, we'll talk about that a little bit later. Okay. Now, the thing is, KPC is rarely found in India. Only 1 to 6% of isolates are there which are KPC positive in India. India, the major problem is class B enzymes, NDM. Okay. And class D, OXA 48 like enzymes. Okay. So, okay. And there are certain other patterns which I don't want to go deep into because you might get confused, but I'm trying to simplify it as much as possible. Am I able, like, are you able to understand or not? Okay. Then comes class B, which is the problem in India. In that, you have to remember NDM. Okay. Then we remember all of those are there, but don't worry about it. NDM is the one which you have to remember. Okay. NDM destroys everything except estrogen. So I thought you should know this. Okay. So I told you, right? The three classes are serine, and the fourth class is metallo-beta-lactamase, right? Class B is metallo-beta-lactamases. Class A, C, and D are serine proteases. Okay. Why does it matter? So imagine. So serine proteases is what? Basically, they form a covalent bond with beta-lactam ring, and then they cleave it, right? And then they cleave it. So beta lactamase inhibitor that we give, sulbactam, right, tazobactam, right, avibactam, veborbactam, relebactam, all of those which we give, what they do is they bind with those serine proteases and then they form a bond which is unbreakable. So they do suicide inhibition of these serine proteases, right? And that is why beta lactam ring is not destroyed now. So beta lactam ring is fine, so they can go and bind to the penicillin binding protein, and the drug can work. So that is how these beta lactamase inhibitors work. Okay, but for class B enzymes, for metallo-beta lactamases, there is no bond. There is no covalent bond. There is zinc, which basically pulls in two molecules of water and then cleaves the beta lactam ring. So there is no bonding happening. So these beta lactamase inhibitors, they can't bind to anything. They have nothing to bind to. So those don't work against class B enzymes. Okay, those don't work against class B enzymes. So only thing which somehow gets left out by destruction by these class B enzymes is estionam, which is the only monobactam in use. There are multiple monobactam which came, but nothing is in use. Only estionam is the only sole monobactam which is in use is estionam. So only estionam is in use against monobactam. Then cefiderocol has come, and now we have one thing which has just come, okay, Zynic, okay. So that is Zidebactam basically, cefepime Zidebactam. So that is, they are saying that it is working against NDM. But before this, we only had Estunam and then Cefiderocol came in. But in India, Cefiderocol is not available. So we only have Estunam. Okay. Did it make sense? Did it make sense? So NDM, everything is destroyed except Estunam. Okay. You want me to move this to top right corner here? Is this better? Okay. 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 So everything is destroyed except for Estunam. Okay. It will all start making sense. If you can understand, if you can follow what I'm saying, it will all start making sense. Okay. Now it will all start making sense. Okay. Then comes class D. Okay, we talked about MC, right? Class C is MC. Then class D or OXA enzymes. Okay, some OXAs are ESBL, but the majority of OXA which we see in India is OXA 48 like enzymes. So there are multiple. So do you know there are total 1500 beta lactamases in circulation? 1500. Okay, you possibly can't remember everything, right? So we have classified them like, SHE 1, 2, 3, 4, like that, like this OXA 48, 15, 150, 200, something like that. Okay, we have gone till there. Okay, there are 100, 1500. So basically, Bush Jacobi, that is why it's a better classification because phenotype associated classification. But I prefer AMLA because I think earlier I like started reading about AMLA and it became like it's an older one, right? So it became I became more comfortable with this. Okay, so OXA basically OXA in India you find OXA 48 like enzymes. Okay, so those this basically they destroy. They are carbapenemase, so they destroy everything except maybe the extended spectrum cephalosporin, third and fourth generation cephalosporin. They sometimes they don't destroy, but what happens is OXA 48 will never come alone. It will always come with some other enzyme, either with NDM, either with ESBL or something like that. So you will rarely see a sensitive pattern for this, but if you see, you can sort of think, okay. So more or less you will see everything resistant. Okay, everything resistant, more or less you will see. Okay. OXA 23 like enzymes are most commonly seen in Acinetobacter, and then OXA 48 like enzyme is what the other enterobacterials will have, and that is what we usually come across. Okay, that is what we usually come across, and it is the most common OXA like pattern in India, which you will see. Okay, okay. So KPC is found in these countries. See, India is empty, although the map is basically the Southeast Asia. KPC is not a problem. It's mostly problem around in Americas. Okay, so America. I mean, I don't know why I'm saying this, but whatever. So my geography isn't very great. So NDM is basically opposite of KPC. Okay, NDM, the problem lies in the Southeast Asia region. Okay, the class B jo enzymes are, the amino class B enzymes are basically the problem is in Southeast Asia region. Okay. Now, whenever these carbapenemes are coming, they don't come alone. They come together. So with KPC, you will find Vim as the most commonly other common, accompanying NDM. Okay. With OXA 48 type enzyme, you will find NDM as the most common presenting enzyme. With NDM, obviously, you will find OXA 48 as the most common presenting enzyme. Okay. So they come together. So with like OXA 48, you might find NDM, you might find ESBL. Okay. So they never come alone. With if NDM is coming, it might come with some other aminoglycoside enzyme. Okay, and some other enzyme. So you will find them in group together. Okay. So most commonly it is 16S methylation issue which comes together with NDM, but whatever. So they never come alone. Okay, so you will not see a very clear cut pattern, and that is why everything will be resistant. Okay, not just those drugs which we talked about. That is why aminoglycosides will also be resistant. That is why fluoroquinolones will also be resistant. That is why trimethoprim sulfoxazole will also be resistant. Okay, but when we talk about just this pure pattern, what we discuss is what you will see. Okay, now, like, it should start making sense. So imagine if you have a bug which has NDM, it should be resistant to every penicillin, or every, sorry, beta lactam in the sensitivity report except for estrogen. So everything is resistant. Meropenem is resistant. Ertapenem is resistant. Ceftriaxone is resistant. Ceftazidime is resistant. Cefepime is resistant. Right? Piperacillin is resistant. Tazobactam isn't working. Avibactam isn't working. Ceftazidime avibactam isn't working. But estrogen is sensitive. So think, what will you think? Oh, this has to be NDM, right? This has to be NDM. So see how it all starts to come together. Did it make sense? We will see. We'll see examples. But did it make sense? Why we had to discuss everything? Many have dropped. 184 are here. Did it make sense? Okay. So this is what we have talked about till now. Okay. If you want, you can take a picture of this. Uh, this is what we have talked about till now. So penicillinase will destroy penicillin. Okay, broad spectrum beta lactamase class A, like the earlier generation TEM, TEM1, TEM2, and SHB1. So they destroy first and second generation cephalosporins, right? Oxa also, some of them, the earlier ones, they destroy same ESBL kind of a pattern, right? But ESBL also, along with this, has a destruction for third generation cephalosporin. Now they are saying for fourth generation cephalosporin also, and estronam. Okay, MC destroys everything till third generation cephalosporin, leaves fourth generation cephalosporin and carbapenems. Okay, okay, and carbapenemases destroys everything. Okay, carbapenems, estronam, okay, beta lactamases, inhibitors. Okay, fourth generation cephalosporin, so everything. Okay, and class B, everything except estronam. Okay, everything except estronam and oxa, the class D oxa, the carbapenemase. So basically everything. 48 like enzymes have this for extended spectrum beta lactamases, sorry, extended spectrum cephalosporins. They might they might be sensitive. Okay, they might be sensitive, but they never come alone. So don't depend on it. They never come alone. Okay, so these also they become unusable basically. But for for the sake of knowing, you should know that they might be sensitive. Okay, okay, they might be sensitive. Okay, so how does so I've told you, like, this is all starting to make sense now a little bit, but laboratory have a way to diagnose it. So there are ways which laboratory can use to diagnose. Okay, so for ESBL, they can use the other tests to diagnose. Okay, they can depend on ceftazidime, clavulanic acid, and all of those things. They can depend on this. For CREs, they can depend on boronic acid and EDTA and all of those things. Right? For AMC also, they can depend on cloxacillin synergy and all of those. So they can diagnose. The laboratories have ways to diagnose these things. Okay, but most laboratories sometimes don't. Sometimes they will give you, like, in at the end of the we'll see some of the reports. At the end of the report, they will see ESBL detected or something, CRE detected or something like that. They will say something like that because they have ways to diagnose this. And there are other tests which you can use, MSIM, eSIM, all of those, CARBA-NP, and all of those tests you can use to detect these enzymes. Okay, you can use to detect these enzymes. And then there are molecular assays, right? There are whole genomic sequencing and all of those things. BioFire is the most commonly used one, where you see this BLA, KPC, BLA, NDM, BLA, CTXM, and all of those. You get the report, right? So this is what, and if you have BLA KPC or if you have BLA, CTXM, it doesn't mean that it is getting expressed. It is just telling you that the gene is there, but is it getting expressed? That also is one of the things. But anyways, forget about it. Don't first understand the basics, then read more in depth. Okay. Now, Coming to beta lactamase inhibitors. So beta lactams, so like the Undertaker, okay, beta lactamase came and destroyed the beta lactam. Now beta lactamase inhibitors, they basically help beta lactam. So that is why BLBLI or beta lactam plus beta lactamase inhibitors, BLBLI, are the most commonly used drugs now. Piperacillin tazobactam has become one of the most commonly prescribed drug and most commonly abused drug as well. So it's a beta lactam with beta lactamase inhibitor, right? Cefoperazone sulbactam, ceftriaxone sulbactam. Some people are also using for some reason meropenem with sulbactam. I'll show you why it is illogical. You'll understand in the next slide. Okay. So what do these enzymes inhibit? So clavulanic acid will inhibit narrow spectrum, and for the sake of theory, ESBL as well. Okay. Sulbactam similarly narrow spectrum and ESBL as well. Okay. So let's say you're using meropenem. Okay. Let's say you're using meropenem with sulbactam. Meropenem is not getting destroyed either by narrow spectrum nor by ESBL. Then why do you need sulbactam along with it, right? You don't need sulbactam along with it because sulbactam is not going to help meropenem anyways, right? It is not getting destroyed either by narrow spectrum or by ESBLs, right? Tazobactam also similar to clavulanate. Now the newer ones, the DBO ones, okay, avibactam and the boronic acid ones, Weberbactam, okay. So these have much larger extent of coverage, okay. So avibactam works against carbapenemases except class B. I told you why it doesn't work for class B, right? Because the zinc, there is no covalent bond happening. Zinc destroys it with water, so there is no bonding happening. So, basically it can't work. But it works for OXA, it works for KPC. Okay, it works for OXA, okay, KPC, and it works for AMC, it works for OXA. Okay. So, similarly, relebactam and vaborbactam, they work for KPC, not for OXA. Okay. They work for KPC. So, in US, you will see meropenem vaborbactam combination. In India, you won't see because India doesn't have a problem of KPC. But US has a problem of KPC. So, there they have a use of meropenem vaborbactam. But in India, there is no use for meropenem vaborbactam because we don't have a problem of KPC. If we start using meropenem vaborbactam, basically we are wasting our time and energy and money, right? There is no use. See, if you want to use a book, if you want to use a resource, I have, give me a second. Give me a second. Where is it? Oh, sorry. Oh, something happened. One second. What did I do? Mm, my is it visible? One second. One second. One second. If you want to use a book, is it visible? Yeah. So this is Antibiotic Explorer. You guys know I've made it. So everything we are talking about, right, laboratory interpretation, mechanism of action, bacteria, everything is there. So for example, in laboratory interpretation, you have everything. You can read through, what are breakpoints, what are MIC. Even like updates are there. Like 2024 updates are there. Yeah, 2024, 2025 updates are there. Give it a second. Why isn't it working? Yeah. See. So ideas 2024, U class changes, everything is there basically. Right. There's a lot more. You can uh, check it out if you want, but there is no complete book for everything. Okay. There is no complete book for everything. Okay. Anyways, let's continue. One second, where was I? Um, Here. Okay. Is it visible now? Is it visible now? Is it visible? Okay, so yeah, so avibactam. Okay, so you didn't understand avibactam. So avibactam, the newer DBO1, basically works against everything which where tazobactam works. It also works for KPC and OXA. Okay, KPC and OXA. Veborvectum works better for KPC compared to avibactam, but if you read the 2026 IDSA guidelines, they don't say that you should use one over the other. They don't say that you should use one over the other, but when you read the inside text, okay, when you read the inside text, then they tell you that they the panel prefers Weber-Vectum over AV-Vectum for KPC. Okay, but KPC is not a problem in India, so you don't need to care about it. Okay, you don't need to care about it. Okay, uh, now, so basically, what we have talked about KPC, it's from class A, right? Inhibited, it is inhibited by avibactam, it is inhibited by vaborbactam, it is inhibited by relibactam, right? The metallo beta lactamases, NDM, imp, right? They are not inhibited by any of these. Oxa is inhibited only by avibactam. Okay, nothing, not by vaborbactam, not by relibactam. And in India, the problem is NDM and OXA48 like enzyme. So in India, relibactam and vaborbactam is of no use. Okay, is of no use. Okay, the same thing. You know the KPC3, even like it is resistant to avibactam as well, but it gains back some of the meropenem sensitivity. So anyways, so basically this is the gist of everything. All the new drugs, estrogen, avibactam. In India, it will work for both for OXA48 and for NDM, right? Both for OXA48 and for NDM. So if we have, and like I told you, right, NDM comes most commonly with OXA48. OXA48 comes most commonly with NDM. So which drug should you use? Estrogen, because it works for both OXA48 and NDM. So we didn't have Emblavio or Estunam available in India very recently. So we were using Zevicefta and Estunam or Ceftazidime Avibactam with Estunam, and we used to give them together in a prolonged infusion over 3 hours or so, and that is what we were doing. Okay, but now we have Western Avibactam available in India, so you can use. Cefdoracol still it's very difficult to arrange in India. It gets imported, very extremely costly. It works for everything. Okay, it works for everything. It has a Trojan horse like mechanism, so that is why it works for everything. Okay. Ceftazidime avibactam does not work for MBLs. Okay, does not work for MBL and for Acinetobacter baumannii oxa and also for Cinetrophomonas maltophilia. Okay, ceftolozane tazobactam is mostly only preferred for Pseudomonas. Okay, mostly only preferred for Pseudomonas. Okay, so similarly other drugs. Okay, so this is a good slide which you can take a picture of for your later reference. So these drugs basically works against all of these. Okay. Now try to guess the enzyme with what we have learned till now. Okay. We'll play a game. I told you how I read antibiograms, right? So this is the everything was coming till here. I hope some of you have understood. Did I make sense? But is my voice breaking? Somebody is writing that my voice is breaking down. Are there people here? Yeah, somebody saying no. Uh, did you guys understand till now what we talked about? Can somebody, if you have, can somebody tell me which enzyme do they think it is? With what is the resistance pattern? People are saying my voice is not breaking. I'm sorry, Sushil. I don't know why you had problem. Yes, Dhyanesh said ESBL. Uday Shinde said ESBL, and that is correct. So think ampicillin, penicillins are resistant, right? Ciprofloxacin is resistant. Ceftriaxone, ceftazidime, so third generation cephalosporins are resistant, right? Cefepime, fourth generation is also resistant, but cefoxitin, okay. Cefamycin is sensitive. So that is one clue. Cefamycin is sensitive. Now the thing is, you won't see cefamycin in non-fermenters, okay? In non-fermenters, it is not used. So when the laboratory is giving you a non-fermenter report, like for Pseudomonas, they won't give cefoxitin screening. So cefoxitin, if it's there, it might help you in catching this, but you might not see it everywhere. For fermenters, for lactose fermenters, they will give you the report. Like for E. coli, they will give you cefoxitin most of the time. Sometimes labs don't give, but most of the times they will give you. Okay. Cefoxitin is sensitive. So then see, so aztreonam is resistant, right? Ertapenem, meropenem are sensitive. So this is not destroying the carbapenems. So this can't be a carbapenemase, right? This is destroying first generation cephalosporins, penicillins, first, second, and third generation cephalosporins, and aztreonam. What do you think it is? It has to be ESPL, right? This has to be ESPL. And when you are adding tazobactam and clavulanate, these drugs which were earlier resistant will become sensitive now, right? These drugs will become sensitive now because this is an ESBL and tazobactam like works against ESBLs. So this is most likely a CTXM M15 pattern. And I'm telling you why M15. I'll give you some additional information. Usually, so CTXM, right? The name suggests cefotaximase found in Munich. So CTXM, right? So CTXM usually has a thing for third generation cephalosporins, okay, uh, or cefotaxime basically. It usually doesn't have a thing for ceftazidime. Okay, so sometimes you will see that ceftriaxone or cefotaxime will be resistant, but ceftazidime will be sensitive, and that is a trap. So people, what they do is they prescribe ceftazidime, but ceftazidime will also fail. Ceftazidime will also not work because for the all intent and purpose, all third generation cephalosporins are useless against ESBLs. Okay, for all intent purposes. Now, even fourth generation you shouldn't be using. So you should not be using cefotaxime. But for what happens when M15 is there? So M15 will also be resistant to ceftazidime. Okay, will also be resistant to ceftazidime. So that is why this pattern. This is M15 pattern. Okay, this is M15 pattern. CTXM M15 pattern. Okay, which enzyme is it? So like we have basically figured out. So this is M15 pattern. Okay, so you see here. Here also you have the similar pattern. Okay, you have similar pattern. Okay, so when you have added clavulanic acid, it has become sensitive. Otherwise, ampicillin was resistant. Okay, so ticarcillin is resistant. Okay, piperacillin tazobactam is resistant. Sometimes that can also happen. So that is why they don't even, for treatment of ESBL, even piperacillin tazobactam is not advised. Even though tazobactam and clavulanate are bringing back the sensitivity, but they are not advised to be used. Because read about Merino trial and read about what is inoculum effect. Okay, I'm not going to go into the detail of it because it is already 10. So let's wind down the class quickly. So read about it. Okay, read about it. Only carbapenems and so on are advised. Carbapenems are basically advised whenever the patient has bacteremia with ESBL. And you know what is the percentage of ESBLs in India? According to 2024, ICMR survey, we have approximately 60 to 80% of ESBLs in our population, in community. It is absurd. Like we have made the drugs which we love the most unusable. This is absurd, guys. I mean, I'm telling you, this is absurd. We I if we are taking care of our health, right, we are working on our cardio, we are working on our lifestyle and everything, we will die of infections, we won't die of lifestyle diseases. So this is absurd. Okay, Okay. How is, one second. What are you talking about? In here. Are you talking about here? Are you talking about here? Okay, so this is also ESBL. So, okay, and even the lab has given that, there is ESBL. They have detected ESBL here. Okay, this is also ESBL pattern. Similarly, this is also ESBL pattern. Okay, this is also ESBL pattern because imipenem, meropenem, and ertapenem are sensitive, so this can't be CRE, right? And when you're adding tazobactam, the sensitivity is coming back, and it is resistant to first, second, third generation cephalosporin. And where is cefepime? It is SDD. Now, this is a homework for you. Read about SDD. Okay, what is SDD? Okay, read about SDD. Okay, so this is also ESBL. These are both ESBL patterns. Okay, now can you guess the enzyme for Pseudomonas aeruginosa ET aspirate? If the amikacin is sensitive, then there is role for amikacin because ESBL doesn't mean that amikacin will not work, right? ESBL might come along with some genes which are resistant, like, aminoglycoside might become resistant because of those other genes, not because, you know, because of ESBL. Okay, so if amikacin is sensitive and good MIC, then you can use it. Okay. Okay, so two, three people are saying ESBL, somebody is saying MC. So, first of all, with the MC, you have to know that not all species will produce MC. Okay. There are some species which can produce AMC. There is a very common mnemonic which is used, space or spice pathogens, but IDSA recently they are advising to not use those mnemonics. They are only saying two, three species are there. Okay, so only in those species you have to worry about AMC. So there are high chances of MC, moderate chances of MC, low chances of MC. Okay, so a lot of other species are there. So E. coli is one of those species. Pseudomonas acinetobacter is Pseudomonas, no. So yeah, ESBL. But in Pseudomonas, the most common ESBLs are not CTXM; they are VB or PER. Okay, so this is probably PER or VB. Okay. Uh, So Verona extended beta lactamase is, uh, you know, VB. So this is a place in Greece or Italy or something. Verona is, I think, in Italy or something. Okay. So AMC with efflux can mimic this, just not just AMC. Okay, not just AMC. Okay. Now what is this? Can somebody guess this? Now, this must be easy. I think I've already uh, talked about it. Klebsiella pneumoniae. Again, people are saying MC. Is Klebsiella pneumoniae MC? Can the bug produce MC? Is the question first. Yes, this is NDM. See the pattern. Piperacillin, tazobactam, everything is resistant, right? Cefepime, third generation cephalosporin, fourth generation cephalosporin, right? Meropenem is resistant, imipenem is resistant, ertapenem, so carbapenemase. This is a carbapenemase, right? With everything is resistant. Avibactam is also not bringing back the sensitivity. So this can't be KPC or OXA. If it was KPC or OXA, avibactam would have brought back the sensitivity. But one another clue is Astronam is sensitive. So Astronam sensitive. If it was any other like ESBL or AMC or KPC or OXA, this would have been resistant, but only for MBLs, only for class B Ambler, this is sensitive. So there you have two hints here. Okay, so this is NDM. Okay, this is Klebsiella also. When one of the most common bug that you will find to have NDM is Klebsiella, and then you have E. coli, and then in India you have lot in Acinetobacter as well. Okay, okay. So these are the two clues. Okay. So is it making sense, right? People are able to guess. So I think I have taught okay. I hope I have taught okay. Okay. So this, can somebody guess this? Can somebody guess this? Yes, correct. This is oxa. So most of you are getting it right. So see, ampicillin is resistant, amoxicillin caveolate is resistant, piperacillin tazobactam is resistant, right? Imipenem, meropenem are also intermediate, right? So this is OXA 48 kind of like enzyme because ceftriaxone and ceftazine, the third generation, cefepime, fourth generation, so extended spectrum cephalosporins, they are sensitive, but this is a weak carbapenemase. So oxa enzymes are weak carbapenemases. Okay, weak carbapenemases. They are not as strong as KPC and NDM, but they are weak carbapenemases. So sometimes you might see high MIC, especially more for ertapenem compared to meropenem. Okay, and you in the laboratory, tamoxifene is one of the drugs which you use. High level tamoxifene resistance you have. Okay, so in drugs, that is in lab, that is how you classify oxa. But this is a classical oxa 48 pattern. Okay, this is a classical oxa 48 pattern. Another clue: ceftazidime avibactam brings, it is sensitive. Okay, so brings back the sensitivity. Okay, so I mean technically ceftazidime here is also sensitive, but this is classical Oxa 48 alone pattern. You will never find it alone. Okay. You will never find it alone. It'll always be accompanied by either with an ESBL or with NDM. Okay. So you'll never find it alone. Okay. This is Oxa 48 like enzyme. Okay. Oxa 48 like enzyme. Okay. Now, what is this? So there was, so this is a patient in, Serratia marcescens is one of the organisms, and then ceftriaxone was given for 12 days, and then the culture report changed from this to this. What is this? Please explain about MIC and antibiotic choice. Okay, so I'll tell you one thing. Okay, so this is another class altogether. That will be another class altogether. But I'll tell you one thing. Stop comparing MICs of different antibiotics. MICs of different antibiotics will tell you nothing. So there is something called breakpoints. Breakpoints are basically decided by a committee. Right? Okay. So either you use UCLAST or CLBSI breakpoints. Okay. So those breakpoints are decided by a committee. Okay. And this is minimal inhibitory concentration. Minimal inhibitory concentration is basically found out by broth microdilution technique. Okay, and sometimes now we are using all automated, right? Vitek and all of those things. So they find it automatically, but classically it was broth microdilution, not with this diffusion. Okay, so there are different types of culture methodology as well. You might have remember, right? This diffusion, broth microdilution, and all of those. So MIC are different for different bacteria. Breakpoints are different for different those bacteria. Okay, so you cannot compare MICs of two different drugs. Just because one drug has a lower MIC compared to the other drug doesn't mean that drug is better. So stop comparing MICs of different drugs. So that is what I'll tell you, and then it'll be a separate class altogether. It's already 10. I have to finish it. So let's focus on this. What has happened? Can somebody tell me, please? I I'm regretting that I finished my Coke because I'm very thirsty. Mouth is dry. It was initially ESPL. Hmm. NDM with Oxa. Hmm. Anybody? Okay. See. Was it ESBL? No. Cefoxitin is resistant. Cefamycins are resistant, right? So penicillins are resistant, right? Penicillin are resistant, right? Cefoxitin is resistant. Ceftriaxone, ceftazidime is sensitive here. Okay, so this was probably not ESBL. This was probably somebody thought this was a penicillinase or something like that. Okay, and then they started giving third generation cephalosporins. Okay, third generation cephalosporin. So when they gave third generation cephalosporin, what has happened here? So third generation cephalosporins have become resistant, and cefamycin is also resistant. Okay, so cefamycin is resistant, third generation cephalosporin become resistant, but fourth generation is sensitive. Meropenem is sensitive. Okay, so carbapenem, this is, can't be carbapenemase, right? This has to be either ESBL or AMC. Now the clue is fourth generation is sensitive and cefoxitin is resistant. So fourth generation sensitive, U and cefamycin resistant. So these two clues should point you towards AMPC in a species which can produce AMPC. Okay, in a species which can produce AMPC. Serratia marcescens also, although has a low chance of producing AMPC, but it doesn't have zero chance. So Serratia marcescens can produce AMPC. Okay, it is low probability bug to produce AMPC, but it can produce AMPC. So this is probably AMPC. And what happens is in AMPC, so AMC is there AMC can be in multiple come in multiple ways. So there's chromosomal AMC which lives on the chromosome. Sometimes it's always on, sometimes it's repressed, and then there are plasmid mediated MC also which can be transferred. Okay, so AMC always comes with a repressor genes called AMR. Okay, AMPR. Okay, repressor gene. So whenever we give a drug which destroys the cell wall, so the particles of those cell walls, the neuraminic acid particles, they go inside, and then those particles are basically detected, and then AMP are basically it it's basically moved from next to AMP-C. Okay, so then that AMP-C becomes de-repressed and it start expressing itself. Okay, so some drugs can cause higher level of AMP-C expression, some drugs can cause lower level of AMP-C expression, but most of the drugs in cephalosporin penicillin group, they are especially carbapenems. Carbapenems are very known to cause high level of MC induction. Similarly, ceftriaxone is known to cause good, not very high, but decent level of MC induction. Okay, so ceftriaxone can cause AMC induction. So the drug is there, the bug is there, the pattern is there. So this is AMC. If the drug was not there, if the bug was not there, if the pattern was not there, if either of these was missing, so think about AMC. Otherwise, if everything is adding together, this is AMC. Okay, so this is AMC. Okay, okay. Now, can you see this? What is happening here? Only few slides to go. 150 of you are here. Just be patient. Few more minutes. Heteroresistance. Heteroresistance. Heteroresistance is something else. Okay. I've made a reel on it as well. You can read more on Antibiotic Explorer. Shameless plug. भाई कोई तो खरीद लिया करो यार. Anyways, can somebody see what is happening here? Okay, Dinesh Raj is saying NDM. Anybody? Nemesis. What is nemesis? Synergistic positive. Okay, Parv Kumawat is correct. Shami M6117 is correct. Uh, Ahalya Ramchandran is correct. This is so. See, directly jump to where are ertapenem and meropenem. Okay, so these are resistant. Okay, both are resistant. So this is a carbapenem. Okay, carbapenemase. Sorry, this is a carbapenemase. Okay, So which carbapenemase do you know? You know KPC, you know OXA, you know NDM. So this is in Klebsiella, right? So think. So now it can be KPC, it can be OXA, it can be NDM. Okay. Now think. Estronam is resistant. If it was NDM, Estronam would have been sensitive, right? Ceftazidime avibactam is resistant. If it would have been KPC or if it would have been OXA 48, this would have been sensitive, right? So this can't be either of these. So this can't be NDM, this can't be OXA 48, this can't be KPC. What can it be then? It has to be, so for that you have to do this test. Ceftazidime avibactam plus Estronam or Estronam avibactam. Estronam avibactam now we'll start using it more and more, right? So that shall also come in the sensitivity report. So if Estronam avibactam is susceptible, or this is called synergy test, okay. So if that synergy is positive, this is telling you there are two enzymes together. So most likely NDM which comes together with KP OXA 48, I told you, right? So this is both NDM and OXA 48. So this synergy is telling you that when you give something which blocks NDM, which is estunam, and something which blocks OXA, avibactam together, then the sensitivity comes out. Otherwise, everything is repressed. So you have to give both together to make it work. And that is the logic behind using Estronam avibactam in India. Okay. Synergy susceptible. Because in India we have NDM and OXA 48 both together. Did it make sense? Did it help you understand the concept better, catch the bug better? Is it making sense? Now look at the Klebsiella here, not Acinetobacter. You can look at Acinetobacter as well, but I want you to look at Klebsiella here. What is this? Only Asutosh thinks that this class was helpful. Everybody else is mum. Fourth generation sensitive, so AMP-C. Where, right? I'm talking about Klebsiella. Are you seeing Klebsiella or are you seeing Acinetobacter? I haven't seen Acinetobacter myself. Let me see. Fourth generation is not sensitive. It's resistant only. So again, this is a pan drug resistant Klebsiella. Everything is resistant here. Everything is resistant here. Okay. So then the possibility of it being NDM with another CRE or ESBL is very high in India. Along, they might have other things as well, right? They might have other things as well. So you should ask for a synergy test, which I don't think is given here. If the synergy is positive, think of it as NDM oxa and give Estronam avibactam. If the synergy, however, is negative, then God helps those who try. I mean, you have to give basically two the combination treatment should be tried. Okay, combination treatment. So I would have probably given Estunamab victim with if it was in where is it urine culture. So maybe colistin or something like that. Colistin is the last resort drug. Okay, last resort drug. Use it. So this is what we have talked about throughout the class. Okay, so this is the whole revision series, right? Class A, you have CTXM, TEM, SHV, KPC, PER, VV. We have talked about all of these enzymes, right? Carbapenems, only KPC and GES and SME, all of those are the carbapenemases, right? So they destroy carbapenems. Otherwise, carbapenems are not destroyed. Astronam is destroyed, right? Cleveland azobactam, yes, they bring back the sensitivity, but not for KPC. Avibactam, yes, it brings back sensitivity for everything, including KPC, right? In India, you don't find it, right? Sorry, you find ESBL, but not KPC. Okay, so you find ESBL, CTXM M15 is the most common beta-lactamase which you will find in India, but not KPC. Okay, Class B. So these are metallo-beta-lactamases, NDMVM. There are two, three more slides. Okay. So, yes, carbapenems are destroyed. Estunam is not destroyed. Clavulanic tazobactam, they don't do jack shit. They don't do anything. Avibactam, nothing. Right? In India, this is the most common one. Right? Class C, serine, again, MC, they have multiple types, like I said, CMY, DHA, Dharan, DHA is Dharan. Okay, Fox. So no carbapenemase. So no, unless purine loss. So along with the MCU, if you have purine loss, then you might have carbapenem resistance. Again, ertapenem more than uh, meropenem. So estunam variable only when fully depressed. Clavulanic tazobactam doesn't work. Avibactam it works for MC, right? So for more or less carbapenems and fourth generation cephalosporins like cefepime, it works for MC. Okay, or class D OXA 48 like or OXA 23 in Acinetobacter. So carbapenems, so it's a weak carbapenemase, right? So ertapenem first goes and then meropenem, right? Meropenem MIC, usually ertapenem will be resistant, meropenem MIC will be very high. Okay, so that is what you will see in OXA 48 mostly. Estunam, doesn't work mostly. Think it for all intent and purposes. Think of it as resistant. Okay, cleveland tazobactam doesn't do nothing, and avibactam works. Okay, for 48, but not for Acinetobacter. Okay, not for 23, not for Acinetobacter. Okay, for Acinetobacter, for Oxide 23, the treatment of choice is Sulbactam Derilobactam. Okay, when Acinetobacter has NDM, then Sulbactam Derilobactam is not the treatment of choice. But if it is Oxa 23, then it is Sulbactam Derilobactam. Okay. Okay, in India it is very common. Oxa 48 is very common. 23 is also common. Okay. Okay. So again, this is the IDSA 2023, 2026, the latest one. So this is the treatment. So Esonam avibactam for all the OXA 48 and for KPC. For class B, you have Esonam based Esonam avibactam. For OXA and KPC, you have ceftazidime avibactam, not Esonam. Ceftazidime avibactam. But when oxa is coming along with NDM, then you have to give Estunam avibactam. Okay. For ESBL, piperacillin tazobactam for bacteremia should not be given. Okay, should not be given. I'm telling you again, should not be given. Okay. Give meropenem or ertapenem or cefepime and metazobactam. Okay. AMC, cefepime or meropenem. Okay. Cefepime or meropenem. Okay. So this is basically the gist of IDS 2026. You can you read yourself. It is available freely on internet. And this is the end of the slide. I thank you for your attention. If anybody has any questions, 2, 3 more minutes, and we can shut it down. I hope it was helpful. I hope your 1 hour 15 odd minutes. You learned something. It was worth it. Only half of you stayed back. 125 out of 200 something, almost 1,000 people, more than 1,000 have registered, but only 200 some odd have joined, and 125 have stayed back. You can't get the slides. I'm sorry. You can read. You have a lot more on Antibiotic Explorer. A lot more. Okay. So, give it a try if you want. Shameless plug. What in non-ICU, which is the most common what? Which is the most common what? Darulobactam combination. I haven't used it, but I have used high dose sulbactam combination very commonly, 9 to 12 gram. So I use sulbactam high dose. I think it is available in India now, but I haven't used it myself. You can't get the PPT. You can get Antibiotic Explorer. If you purchase it, maybe if you have bought it, then maybe I can give it to you. Thank you, everybody, for appreciating. Yeah, it's already discounted. Yeah, how much? It's one like how much it costs for me to run it. Like it's already discounted. It's lifetime, right? like 5, 10 years at least, it will stay on the web, right? So every cost adds up, and it's not like hundreds of people are buying it, right? Once in a while, somebody will buy it, right? Okay. The price, I'm planning to increase the price, not decrease it. You need more live classes. I would love to do more classes, but I have limited time. But I head a department now, and I have kept my phone on silent. I'm pretty sure there would be two, three messages or missed calls here. Uh, so I mean, it's not easy. It's not easy to take out time. But yeah, I mean, I would love to do more classes. I like teaching. I mean, if you like the way I teach, then maybe we can. Should I do like a more detailed antibiotic course? I mean, it will be paid, it will not be free. If everybody is okay, just I'll put a poll in the group or something, then maybe you can reply on it. Maybe if you're interested, if you guys are interested, if it will be worth my time and effort, then obviously I'll do a more detailed antibiotic course and much more. Obviously, I'll teach you much more than this. In the meantime, you can check out Antibiotic Explorer. Again, I'm shamelessly plugging. Okay, guys, thank you. I haven't seen any questions. No, the live will not stay on YouTube. Thank you. I haven't recorded it. Thank you. Certificate I can give, not a big deal. Certificate is doable. So if you guys are interested in live classes, I might do. I mean, let me know. I'll put up a poll in the group. Okay. Thank you. Bye bye. Good night. It's 10:30. Good night.